Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0498, indicates a low voltage condition in the EVAP canister vent shut valve circuit. This code is pertinent to the 2016 to 2021 Honda Civic, and it specifically relates to the component responsible for managing the flow of fuel vapors from the fuel tank to the charcoal canister. The EVAP canister vent shut valve is located in the vehicle's evaporative emissions control system, typically mounted near the fuel tank or the canister itself. A malfunction in this valve can lead to excessive fuel vapors escaping into the atmosphere, triggering the check engine light and potentially impacting fuel efficiency. The first step in addressing this code involves confirming its presence through diagnostics and using the Honda Diagnostic System, HDS, to gather further information about the issue. It is essential to follow a systematic approach to troubleshooting to identify the root cause accurately. DTC P0498 specifically denotes a low voltage condition affecting the EVAP canister vent shut valve circuit. This circuit is crucial since the vent shut valve controls the entry and exit of fuel vapors in the evaporative emissions control system. Its primary role is to prevent these vapors from escaping into the environment, contributing to air pollution and failing to meet emissions standards. The valve is typically situated near the fuel tank, making it essential to access this area during diagnosis. If the electric circuit to this valve experiences low voltage, it may fail to open or close properly, leading to the triggering of this DTC. Furthermore, it's essential to understand the implications of this fault, as it may not only cause a failed emissions test, but could also correlate with performance issues in the vehicle. Several possible causes can lead to the activation of DTC P0498. First, a faulty EVAP canister vent shut valve can restrict vapor flow, triggering the low voltage code. If the valve itself is operationally impaired, it will fail to function correctly. The next potential issue lies in the wiring connected to the valve. Damaged, corroded, or loose connections can lead to voltage drops and potentially cause the DTC to trigger. Additionally, a weak or failing battery could result in insufficient power being supplied to the valve. The Powertrain Control Module, PCM, which controls the valve's operations, could also be malfunctioning, resulting in erroneous voltage readings. Hence, a comprehensive check of these systems is crucial for accurate diagnosis and resolution. The symptoms associated with DTC P0498 can manifest in several noticeable ways. The most immediate indicator is the illumination of the check engine light, alerting the driver to a potential issue requiring attention. If unresolved, this fault may lead to a failed emissions test, negatively impacting compliance with environmental regulations. Moreover, drivers may notice poor fuel efficiency, as a malfunctioning valve can lead to excess fuel vapor escaping rather than being processed correctly. Lastly, issues with fuel evaporation can also emerge, where fuel vapors are improperly vented, resulting in a further decrease in overall vehicle performance. It is important for vehicle owners to address these symptoms promptly to avoid more severe consequences. The first step in troubleshooting DTC P0498 involves vehicle power management and diagnostic system initialization. Begin by turning the vehicle to on mode. It will power the onboard systems without starting the engine. Subsequently, use the Honda Diagnostic System, HDS, to clear any existing DTCs. Once cleared, start the engine and let it idle for at least 5 seconds without loading it, such as being in gear. After this stabilization period, again check for any pending or confirmed DTCs using the HDS. If DTC P0498 reappears, this indicates that the issue has been duplicated, necessitating further investigation. However, if no DTC is present, one must consider the possibility of intermittent faults that could be due to poor connections or loose terminals. Step 2 focuses on further confirming the operation of the EVAP canister vent shut valve. Using the HDS, select the EVAP test option from the inspection menu, which allows you to access detailed diagnosis of the evaporative system. Conduct the EVAP CVS on test in the single solenoid mode. This helps to engage the valve directly for testing purposes. After performing this test, it is crucial to recheck for any pending or confirmed DTCs utilizing the HDS. If DTC P0498 appears again, it confirms that the malfunction is a persistent issue requiring additional troubleshooting. However, if the DTC does not reappear, this may signify an intermittent fault condition, necessitating checks for poor connections or loose terminals at both the valve and the powertrain control module, PCM. In this third troubleshooting step, the focus shifts to checking for open wires, specifically along the IGPS, or Integrated Power System for the LAF, or Lean Air Fuel line. Begin by turning the vehicle to the off-lock mode, ensuring all systems are powered down. Next, disconnect the 2P connector of the EVAP canister vent shut valve to isolate it from the circuit. With the connector disconnected, turn the vehicle to the on mode to provide power to the system. Measure the voltage between the two specified test points, noting that test point 1 connects to the number 1 terminal of the vent shut valve connector, while test point 2 connects to body ground. A critical component of this process is to establish whether battery voltage is present. If it is, the IGPS line is functional, allowing you to move on to the next step. However, if battery voltage is not detected, further checks need to be conducted involving the number A11 fuse and the wiring leading to the vent shut valve. The fourth step in troubleshooting DTC P0498 entails conducting a resistance check on the EVAP canister vent shut valve to assess its internal condition. With the vehicle turned to the off-lock mode, disconnect the 2P connector from the vent shut valve to ensure an accurate reading. Subsequently, measure the resistance between the two designated test points on the valve. It is important to conduct this measurement while the vehicle remains off, thereby isolating the valve state from any power fluctuations. Ideally, the resistance should fall within a range of 25 to 30 ohms at room temperature. If the resistance reading aligns with this specification, the valve is operating correctly, thereby prompting progression to the next troubleshooting step. However, if the resistance deviates from this range, it indicates a defective valve, necessitating replacement to restore the functionality of the evaporative system. For the fifth troubleshooting step, the focus is on checking for short circuits in the VSV line, where VSV stands for Variable Solenoid Valve. Begin by turning the vehicle to the off-lock mode. Use the Honda Diagnostic System, HDS, to jump the SCS, or Shorting Connector System line, to activate the system shorting mode, and wait more than 1 minute. Then, disconnect the PCM connector A, which has 50 pins, to further isolate the system. Carefully check for continuity between the specified test points, ensuring that the vent valve is disconnected in the process to provide a clear reading. If continuity exists, this would indicate a short in the VSV wire, warranting a repair to ensure that the wiring functions as intended. Conversely, if continuity is absent, it signals that the wiring is not shorted, allowing you to proceed to the next step in the troubleshooting process. The final troubleshooting step focuses on checking for open circuits in the VSV line by establishing continuity between the necessary test points. First, Connect terminals A and B with a jumper wire, where terminal A corresponds to the 2P connector number 2 and terminal B connects to body ground. This step effectively creates a pathway to determine if a circuit is complete. Once connected, measure continuity between test points 1 and 2, which involves the PCM connector A and body ground. If continuity is present, this confirms the integrity of the VSV wire and signals that further investigation into authorized service information may be needed to ascertain any related DTCs or symptoms. Additionally, if a known good PCM can be substituted, it is wise to do so. If DTC P0498 clears up, it indicates that the original PCM may be faulty. Conversely, if continuity is absent, it requires repair of the open circuit in the VSV wire, ensuring that complete communication exists between the PCM and the EVAP canister vent shut valve. After completing all troubleshooting steps for DTC P0498, it is crucial to conduct a final repair verification process. Start by clearing any DTCs present using the Honda Diagnostic System, HDS, to reset the vehicle's onboard diagnostic system. Following this, conduct a test drive of the vehicle under varied driving conditions to ensure the repair was successful and the system is now functioning correctly. After the test drive, use the HDS to monitor for any reoccurrence of DTC P0498. This final step is critical as it ensures that not only has the original issue been addressed, but also verifies that all components and connections are functioning optimally. If the DTC does not return, this points to a successful repair, while reappearance suggests further investigation may be required. To prevent the occurrence of DTC P0498, routine maintenance of the evaporative emissions (EVAP) system plays a crucial role. Begin by regularly inspecting the EVAP components, such as the canister vent shut valve, for signs of wear or damage. It is also essential to check the electrical connectors and wiring for any signs of corrosion, fraying, or loose connections that could disrupt voltage flow. Furthermore, ensuring that battery terminals are clean and securely connected is vital, as a weak or poor quality power source can lead to low voltage conditions. Adhering to a disciplined maintenance routine can significantly aid in early detection of potential problems, ultimately prolonging the lifespan of vehicle components and maintaining optimal performance. In summary, DTC P0498 is an important diagnostic trouble code that denotes a low voltage condition within the EVAP canister vent shut valve circuit. Effective troubleshooting begins with confirming the issue through a structured approach, utilizing the Honda Diagnostic System, HDS, for comprehensive diagnostics. Identifying and addressing potential causes such as wiring issues, a faulty vent valve, or battery problems is vital to repair the issue effectively. The final verification process ensures that the repairs have not only resolved the fault, but also re-established optimal function of the evaporative system. Additionally, preventive maintenance measures can significantly improve reliability and reduce the likelihood of future emissions-related DTCs arising. Understanding the implications of DTC P0498 encourages prompt attention and systematic problem-solving, which ultimately contributes to the overall performance and efficiency of the Honda Civic. Please like and subscribe to the channel. See you next time.